and I'm going to record this. The following diagram shows 3 cities, A, B, and C. City B is 70 kilometers from A on a bearing of 130. Remember what I said, bearings come from a north direction heading which way? Clockwise. So there's that north, and then there's that angle that makes 130. City C is 40 kilometers from B, and it's on a bearing of 75. Again, from the north direction, heading clockwise, that's 75 degrees. Okay, a picture's provided for you, which is very nice. Now you're asked to find angle CBA, this full angle right here. I know part of it's 75, but what's that part that's missing? How do you know? Well, they're actually not opposite. Well, they're actually on the same side. If that's 130, this one would have to be 50.
And then that's 50 because of A, like, goes up, down.
These are called, the ones that are in the diagram, they're called consecutive interior or same side interior angles, and they're supplementary. Okay, they do have to add up to equal 180. So what's the angle of CBA? 125. Now you're asked to find the distance between city A and city C. City A and city C. What rule am I going to use here to find that distance? Side angle, side. Cosine. Do it now. You're doing the cosine rule and finding the distance from city A to city C. All right, what we get?
98.5.
98.5. Very good. And don't forget your units, kilometers. We would use the cosine rule here. That it was essentially, since I'm looking, in case you guys did not know this, and I didn't realize how this was not common knowledge. The side across from angle A is side A. The side across from angle C is side C, and the side across from angle B is side B. So in your formula, since I'm looking for side B, it would have been B squared equals A squared plus C squared minus 2AC cosine angle B. To actually find B, I would need to take the square root. That way you won't have a number in like the 9,000s, because that's definitely too large. So when I plug everything in, it should have been 40 squared plus 70 squared. Really, truly, it could have been either way as long as it's the 2 adjacent sides. And then 125. What mode is your calculator in?
Degree.
Yes. Which one?
Degree.
Degree. I said radian for a second. Now, if I wanted to travel to city A directly to C, find the bearing you will need. So if I want to travel from city A to C, find the bearing you would need. Now, that is talking about this part that I'm highlighting in green. Not the full 130, but that part that leads me up to that purple line. How could I find that green colored arch? Find angle A in the triangle, and then what?
Sorry, add it to 130.
No, you had it right first time. Yes, I'm going to want to figure out what the angle is on the inside of that triangle at angle A. So then that way I can subtract it from the 130. So how do I find this angle here? What am I going to use to find that angle? I'm going to use sine because I'm looking for angle A and I have side A. I'm going to set that equal to what? What other piece of information do I know to use sine rule?
Side B.
Side B. and angle B, which was,
You'd have to use the full number, right?
I'm gonna have to use that full number, so it should still be sitting in your calculator, right? If you did it. And so then I would use the full decimal because the more you round, the further off you're gonna be. So this becomes 40 sine of 125 equals that long decimal sine of A. How do I find angle A?
Just divide the long number by.
Divide the long number, and then how do I actually solve for A?
You say, no.
Well, I mean, 125. Yeah, you just do the 40 sine of 125 divided by -8, and then the whole number.
Okay, so I'll have sine A is equal to this whole thing. I haven't solved for A yet. How do I actually solve for A? How do I get A by itself?
Divide sine, wait.
There's no such thing as divided by sine. I gotta do the inverse. A is an angle, so I need to do the inverse. Anytime I'm looking for an angle, I do the inverse of that trig function. That's how I find angle A. That is how I find angle A. What did you get? So you get roughly about 19.4, right? But since I'm looking for the bearing, I want to subtract that number from 130. So then I round. What is the bearing? 111. Very good.
You have to write it as a 111.0, right?
No, just 111. Because it's already three significant figures.
Okay.
Because it was originally 110.5. So then that 5 cost you to round the 1 up. It wasn't like 99, because then that's when you put the 0.0. Last thing, it says to find the area enclosed by connecting 3 cities in a triangle. So I'm looking for the area of this general region. Do I have side angle side in this triangle?
Yes.
When you look, you found this angle to be 125. This side was 40 given to you, and this side was 70 given to you. To be honest, I'd rather use this with the 125 versus using 70, the 98.5 number, and the angle for theta, because we had to find 2 of those things. All right. At least then we only had to depend on our knowledge of angles to find the 125. So it'll be 1/2 70 times 40 sine of 125. Type that in, round to 3 significant figures, and tell me what you get.
Um,
1,150. Very good. And this will be kilometers squared. The number before you actually rounded was 1146.8. Remember, 1, 2, 3 significant figures, but you need the placeholder for the 6. The 6 causes the 4 to round up, and that's how we get 1150. Then very quickly, I'm going to talk you guys through this. In the shaded region below, the radius of the smaller arc is 6 centimeters, and the distance between the 2 arcs is 4 centimeters. Okay, find the perimeter of the shaded region. Perimeter, that's all the sides added up. That is these 2 small segments right here, which are both how long? And then it's this piece, AKA the, what is that called? It would be the arc, what? Length. Not to be the arc length. And then it would also be this piece right here, which is another arc length. So the perimeter of the shaded region would be the 2 4s, the smaller arc length, and then the larger arc length. So to find the smaller arc length, it is theta over 360. What's theta?
140.
Times 2 pi r. What is the radius of the smaller arc? 6. Plus theta over 360 times 2 pi r again. But this time it's for the larger arc. It's 10 for the larger arc, and the angle is still 140. This is how you would find the perimeter of the shaded region. Does everybody see where we got 10 from?
Yep.
It's the sum. Then to actually find the shaded region, anybody know? Have an idea? Area formula. How to find the area of what?
Find the area of the smaller circle, well, smaller portion of the area of the bigger portion.
Exactly. I'll have to find the area of the bigger sector and then subtract it from the area of the smaller sector. So that would be 140 over 360 times pi r squared. What's the radius of the big sector? 10. Then I will subtract it from the area of the small sector. What's the radius of the small sector? And that is how you would find the area of the shaded region. So then your answer to part A of the perimeter should have been 47.1 centimeters. And remember, a perimeter and length are measured in just regular units, so it would just be centimeters. And then for the area of the shaded region is 78.2 centimeters squared. And remember, area is always squared units. So this is area of sectors as well as bearings. These were the two examples here to go along with the other video.